Hello, my name is Ava, and today we're going to be talking about target number 3 from this test. So let's go ahead and start by reading the problem. It's a big one. So we know that a dock has 90 different flags, all of which are triangles, and Emma observes that 48 flags are scalene, 40 flags have the angle measure of the largest angle greater than or equal to 90, so those would be obtuse triangles or right triangles if it is 90 degrees. And 24 flags are right scalene triangles, and 2 flags are obtuse scalene triangles. Emma also observes that 20% of all flags that are acute triangles are equilateral triangles. So those would be triangles with all 3 side lengths being the same. And we want to know how many flags are acute isosceles triangles, but not equilateral triangles. So these are triangles with angles all less than 90 degrees and 2 sides are the same, but not 3. So there's a lot of different information here, a lot of different categories. And the way I started to approach this problem was by creating a table. And it looked like this. So we have information about the angle on the top, which is right or obtuse, so 90 or above, or acute. All angles are less than 90 degrees. And then information about the type of sides, whether it's a scalene triangle with all 3 sides being different, or if at least 2 sides are the same length. And these would be our isosceles triangles and our equilateral triangles. And from there, I looked at the question stem and I started to plug in what we know just from what the question has told us. So we know we have a total of 90 different flags. So that can go down here in our totals category. And we also saw that Emma observed 48 scalene triangles. So that goes here. And that problem tells us that 40 flags have angles that measure 90 or above. So that would go here in our right or obtuse triangles. Problem also says that 24 flags are right scalene triangles. That goes here. And 2 flags are obtuse scalene triangles. That also fits in this category. And 24 plus 2 is 26. So we have 26 scalene triangles that are right or obtuse. Our table looks a lot fuller now. And just considering the information we have, I think we have enough data points to fill in the rest of it. So from there, I figured out how many acute and scalene triangles there are, which we know because there's 48 total scalene triangles and there's 26 right or obtuse one. So there has to be 48 minus 26 equals 22 acute scalene triangles. We can do the same thing down here to figure out how many right or obtuse triangles there are that have at least 2 side lengths, that have at least 2 sides that are the same length, and we get 40 minus 26 is 14. And the next step I did was to fill in these total categories, which I did the same way. There's 48 scalene triangles, which means there has to be 90 minus 48 equals 42 triangles that have at least 2 of the same side lengths. And by the same process, there's 40 right or obtuse triangles and 90 total triangles. So there has to be 90 minus 40 equals 50 acute triangles. We have one last empty box in our table that can be filled in as well, because we know that there's 50 total acute triangles and 22 of those are scalene, which means that 50 minus 22 equals 28 of those triangles have to have at least 2 sides that are the same length. Well, now we know how many different triangles fit in each different category. So from there, I consider the part of the problem that says that 20% of all flags that are acute triangles are equilateral triangles. Well, we know we have 50 total acute triangles, and 20% of 50 is 10. So that means we have 10 triangles that are acute and equilateral. And we know that we are looking for acute isosceles triangles, but not equilateral triangles. So of our 28 acute triangles that have 2 sides that are the same length, which are our acute and our isosceles and equilateral triangles, 10 of those are equilateral, which means that 28 minus 10 equals 18 of those are isosceles. So that's our answer, and there are 18 acute isosceles triangles that are not equilateral triangles of all of our different flags on this dock. Thank you, and I hope this helped.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.